Welcome to Spaceverse, your portal to cosmic adventures. It's almost there. SpaceX Starship Ship 30 is ready for its next launch, but it still needs additional testing. Starbase's Starship Tower 2 is rising at an accelerating pace. Will it be completed in time? Is SpaceX really considering dismantling the ISS for NASA? Why is NASA's Moon Rover being replaced by concrete? These developments could be crucial for future life on Mars. Could this mean humans could eventually live on Mars? SpaceX Starbase remains the only facility in the world equipped to handle a full Starship launch, truly one of a kind. But how does SpaceX achieve all this? Let's dive into their latest activities. Take a look at Pad B, which is expanding rapidly. SpaceX is transitioning from one Starship launch pad to two, which will double the launch frequency and provide redundancy for the projects. As mentioned in the previous episode, the tower's second module was installed on top of Section 1 and the base on July 16. The complete tower will consist of 9 of these modules when fully assembled. Shortly after adding the module, the massive CC 8800-1 crane used for stacking the tower was detached from the section. The load spreader, which evenly distributes the module weight, was then lowered to the ground, and the module load spreader was disconnected from the crane. Wouldn't it be quicker to keep the crane ready since it's only needed to lift sections of the second tower? That's a great question. The large Saren's crane isn't just used for lifting the modules, it also played a crucial role in installing the elevator shaft inside Module 2. This shaft extends the full height of the tower, essential for accessing the upper levels and transporting people and materials. With the tower standing at 469 feet or 142 meters, it's one of the tallest launch structures in the world, built to support the most powerful rockets ever created. SpaceX is racing to finish the second Starship tower as quickly as possible. That night, Module 3 was seen rolling down Highway 4 to the launch site, and by the next day it was lifted and placed atop Sections 1 and 2. Unlike the previous sections, which were stacked 5 days apart, this module was added just 2 days after Section 2. The stacking was slightly delayed due to Hurricane Beryl, which threatened Starbase. If SpaceX had continued with 5-day intervals, the stacking process would have taken much longer. Instead, they are accelerating the process by stacking segments more frequently. With 3 sections completed and 7 to go, the task is getting more challenging. After stacking Section 6, the DMAG CC 8800-1 crane will be lowered and extended to prepare for stacking modules 7 through 9. If SpaceX maintains a steady pace, the extension should begin in about a week. However, there is a potential roadblock, Sections 4 and 5. These sections were only recently moved to Sanchez, meaning they are lagging behind the other modules. Sections 4 and 5, which were built in Florida, will be the next to be stacked and will house the delicate piping and the electronics for the Starship's upper stage quick disconnect arm. This arm is crucial for supplying fuel and power to the Starship's upper stage, making these modules more delicate and requiring careful handling. Currently, they are at the Sanchez site, next to SpaceX Starship High Base, where they are being prepared with wiring and cryogenic piping for final stacking. Naturally, for SpaceX to stack a Starship with any of its launch towers, it requires giant metal chopsticks. You know, typical rocket company equipment, especially when the goal is Mars. These enormous lifting arms are composed of 3 main parts, the 2 chopsticks and the chopstick carriage. The carriage functions as the lift that attaches to the tower, making the stacking process possible. Last week, we reported on the first chopstick being moved from its storage location at the port of Brownsville, approximately 15 miles down the road, to the Sanchez site at Starbase. SpaceX is storing all the modules for Tower B here, so this move was crucial. 1 part down, 2 to go. On the night of the 17th, the second chopstick made its way to Sanchez. Then, just the very next night, the chopstick carriage was transported to Starbase, completing the set. As a fun fact, this entire chopstick mechanism, along with much of the tower, was transported by barge from Cape Canaveral, Florida to Boca Chica, Texas. This massive logistical effort highlights the scale of SpaceX operations. With the chopsticks finally arriving at Sanchez, all the known parts are now safely at Starbase. The only piece still missing is the Ship Quick Disconnect Arm, or SQD. The absence of the SQD likely stems from SpaceX's decision to upgrade it based on their experience with Tower 1. On the first tower, this arm required extensive repairs after each launch, which is not in line with SpaceX's goal of rapid reusability. They aim to build not only the largest rocket ever, but also make it quickly reusable, including the launch pad. What good is a rocket capable of launching 3 times a day if the pad needs weeks of repairs after each launch? With the chopsticks and carriage in place, SpaceX can now focus on completing Tower B. These lifting arms are essential for stacking the Starship sections onto the tower, enabling the ambitious launch schedule SpaceX envisions. The giant metal chopsticks are a testament to the innovative solutions SpaceX employs to achieve their groundbreaking goals. As SpaceX races to complete Tower B, the importance of these developments cannot be overstated. The chopsticks' ability to lift and position the Starship sections is critical for the entire operation. With the goal of reaching Mars, every piece of equipment and every logistical maneuver brings SpaceX one step closer to making interplanetary travel a reality. Speaking of rapidly reusable rockets, let's head over to the production site where SpaceX builds those massive starships. This place never sleeps. It never rests. The gears of Starbase are always turning 24/7. There are 3 bays here dedicated to starships and boosters. This setup allows SpaceX to deploy their new version 2 Starlink satellites through a small payload door at the base of the payload bay. Relatively speaking, the door is actually about 7 meters wide. This wide but not tall design is crucial because a taller door would require extra reinforcement, which would add unwanted weight to the rocket. More weight means less payload to space. The current design ensures that the Starship has enough strength to withstand the immense stresses of re-entry while minimizing structural bracing. Now the question is, what ship is this new payload dispenser for? Any guesses? It's most likely destined for the shiny Block 2 ship 33, which is over at the high bay. If that's the case, we should see the fully stacked Block 2 payload bay rolling over there soon. All eyes are currently on the Block 2 Starship. Ship 33 promises significant improvements over the current Starship design, incorporating lessons learned from the previous 4 launches. But we saw a different ship rolling to Mega Bay 2, Ship 30. It's still an older design, but it's the next one slated to fly on Flight 5. Even though Ship 30 might still be Block 1, it has some serious upgrades, including a new heat shield. By the end of last week, Ship 30 appeared to have all of its new heat tiles installed, featuring an added ablative layer below and a higher-grade heat tile on top. Will this make it through re-entry? What do you think? Leave your predictions in the comments below. I love reading them. To confirm that the work is indeed finished, the team has finally taken down the scaffolding around the ship. We saw SpaceX remove nearly every heat shield tile from the ship and replace them with new tiles that SpaceX claims are twice as strong as the previous ones. The added ablative layer underneath the tiles acts as a non-reusable backup heat shield if the main heat shield fails. SpaceX is making these upgrades following the last Starship flight, during which the ship's heat shield experienced several issues on re-entry. Returning from orbital velocities is extremely dangerous. But why is that? Falcon 9 boosters seem to handle it just fine, right? Yes, but they don't travel at the same speed. When ships return from orbit, they move nearly 20 times faster than a bullet or 20,000 kilometers per hour faster than a Falcon 9 booster. This speed causes significant heating when entering the atmosphere. This is why reusing a rocket's upper stage is far more difficult compared to the first stage or booster. The upper stage retains all the launch energy in the form of kinetic energy. Anything without a very strong and reliable heat shield cannot survive re-entry. Ship 29 vividly demonstrated this during the last launch. Hopefully, these improvements will ensure that Ship 30 returns with more of its flaps intact than Ship 29. Another major test for these new heat tiles will be an upcoming static fire with Ship 30. After completing the tile work at the high bays, Ship 30 was loaded onto the special crab transport stand, which had arrived at the build site the previous night. On the 20th, Ship 30 was lifted onto the transport stand and rolled to Massey's, where we'll perform a static fire, if it hasn't already done so by the time you're watching this. But why is Ship 30 headed to Massey's test site anyway? After all, we saw a static fire from the ship on May 8th. If you don't already know, here's the reason. After the static fire in May, one of the ship's engines was replaced. It's likely that a problem was detected during the static fire, necessitating the engine swap. SpaceX needs to test the new engine, and what better place to do it than on their brand new static fire stand at Massey's? Ship 30 isn't the only new arrival at Massey's either. On the night of the 18th, we saw the new booster test tank, which had been assembled in Megabay 2, roll over to Massey's and lifted the next day. SpaceX pace at Starbase is unmatched. The daily activity at SpaceX is like a bustling ant's nest, with prototypes, new developments, and launch towers constantly on the move. In a surprising turn of events, a component was lifted into the new Can Crusher 2.0, a device SpaceX designed to test the structural load on Starship hulls, simulating the forces experienced during a launch. It was anticipated that this Can Crusher would be used for Block 2 Starships, and given that this is a Block 2 test tank, it fits. However, what caught many off guard is that Can Crusher 2.0 isn't yet complete. In fact, the next section of the Can Crusher was just constructed last week and is still waiting to be installed beside the new Can Crusher. There are two possible reasons for SpaceX's decision to proceed this way. First, it might be that the full Can Crusher isn't necessary to test the smaller test tank, implying a full-size booster will be tested once this tank is adequately crushed. Alternatively, the next segment might need to be installed after the tank is already in place. But this raises a question. Why was this approach necessary? What do you think? Share your thoughts in the comments below, and let's see who gets it right. My guess is it's to keep the booster from moving unexpectedly. Now that we've covered the latest with SpaceX Starship, let's move on to another significant SpaceX-related development, Mighty Dragon. As some of you may know, NASA plans to deorbit the International Space Station into the Pacific Ocean in 2030. The ISS is getting very old, and NASA has determined that it can't be renovated. Unfortunately, this is necessary because by then the station will be over 30 years old, making it unsafe to house astronauts. NASA, being a government agency, operates under contracts for everything, and this particular contract was just awarded to SpaceX. When thinking about which SpaceX vehicles could undertake this task, two options come to mind: the Dragon capsule, used for transporting astronauts and cargo, and the Starship. Another possibility is the SpaceX Deep Space Logistics Vehicle, Dragon XL. The new vehicle is planned to be used for Lunar Gateway supply missions. SpaceX has dropped a significant hint. According to a new render from SpaceX, they won't be using any of the previously mentioned options. Instead, they seem to be planning a modification of the existing Cargo Dragon 2 into a more powerful vehicle. This modification is necessary due to the ISS's massive size and weight. Despite space being a zero-gravity environment, inertia still plays a significant role, and the ISS has a lot of it: 420,000 kilograms or 925,000 pounds traveling at 17,150 miles or 27,600 kilometers per hour. It's a behemoth. According to SpaceX render, which could still change, the new Cargo Dragon will have 46 of the small Draco thrusters compared to the current 16. This increase will provide 4 times the thrust. With 30 extra engines, the spacecraft will need to carry more propellant. Therefore, the trunk module of the spacecraft will be lengthened to over double its current size to accommodate 6 times the propellant. This design is necessary for a vehicle capable of deorbiting the ISS. Some have questioned why SpaceX's larger rocket, the Starship, isn't being used for this task. The reason lies in the nature of the contract. It appears that SpaceX needed to submit a finalized design to NASA before the contract could be awarded. Given the uncertain fate and anticipated changes to Starship over the next 6 years, they likely didn't want to commit it as the final design. Additionally, the contract stipulates that the vehicle must be able to complete the deorbit on its first launch. This requirement likely led SpaceX to choose the most proven vehicle available. The new Dragon variant, being very similar to the existing model, wouldn't require as much testing and development. It will be both exciting and a bit heartbreaking to witness the eventual fate of this magnificent space station. SpaceX's ongoing testing and development efforts are aimed at paving the way for future missions to Mars and beyond. Meanwhile, let's shift our attention to another Mars mission currently underway. This time, we're focusing on Curiosity, the older sibling of Perseverance. Since its arrival on Mars in 2012, Curiosity has been exploring the planet, including its ascent up Mount Sharp, a towering 3-mile-high Martian peak. At present, Curiosity is investigating Geddes Vallis, a valley on the edge of Mount Sharp. During a June expedition, the rover encountered a large rock that couldn't support its weight. This rock, a geode formed millions of years ago by landslides or water flows, cracked under Curiosity's load and exposed large yellow crystals inside. These crystals, which are pure sulfur, are the first of their kind discovered on Mars. Although sulfur-containing minerals have been identified before, pure sulfur has not. This find is exceptionally rare and highly significant, as sulfur is a critical component of two amino acids that are fundamental to proteins. The area around Geddes Vallis is filled with similar geode-like rocks, which may also contain sulfur crystals. Thus, Curiosity not only uncovered a vital building block of life, but also discovered numerous rocks that may contain more. In contrast, not all missions are successful. Recently, a mission that hadn't even begun was abruptly ended, and the situation is quite dramatic. Enter NASA's Viper Lunar Rover, announced in 2019 as part of the Commercial Lunar Payload Services program. This rover, developed by NASA's Ames Research Lab, was set to be delivered to the lunar South Pole by Astrobotic's commercial lunar lander to explore permanently shadowed regions that might harbor water. However, NASA recently revealed that they are canceling the project, which had already cost $450 million in development due to budget overruns. What a twist! The rover is already finished and practically ready for launch, so it's puzzling how costs have exceeded the budget. The issue isn't with the rover itself, but rather with delays related to Astrobotic's lander. Given the rover's specific mission constraints, it can only be launched during the summer months at the lunar South Pole, which aligns with Earth's summer cycle. This limited launch window means that if it misses the opportunity, it would have to wait another year, leading to higher costs for keeping engineers on standby. Here's the twist you've been waiting for. Even though the Viper rover is nearly ready and has contributed to budget overruns because of delays with Astrobotic's lander, NASA still plans to pay Astrobotic to land their lander on the moon. However, if the lander won't be carrying Viper due to timing issues, what will it carry instead? It turns out that NASA plans to use the funds to have Astrobotic land, a mass simulator, essentially a block of concrete. In other words, NASA is spending a substantial amount to send a block of concrete to the lunar surface. This decision seems short-sighted and, unfortunately, wasn't driven by scientific needs or budgetary concerns, but rather by a seemingly arbitrary requirement imposed by Congress. There's still a chance that Congress could approve additional funding for Viper. With the clock ticking, let's hope that happens. The lunar South Pole is one of the moon's most intriguing locations and is slated to be a key site for upcoming Artemis missions and potentially the first lunar base. Gathering as much information as possible about this region is crucial. A block of concrete, no matter how costly, won't suffice for such an important mission. And that's it. Thanks for exploring the cosmos with us on Spaceverse. If you enjoyed our dive into the latest in space exploration and astronomical discoveries, don't forget to like, subscribe, and hit that notification bell so you never miss a launch. Drop your thoughts and questions in the comments below. We love hearing from fellow space enthusiasts. Until next time, keep reaching for the stars and stay curious. See you in the next galaxy.